Yay, okay, we're finally up here. Sure what happened here, but my recording had stopped. Anyway, here we go again.
Yeah, we solved it.
So what's going on? You found F1 and F2, but that's not exactly the problem. You found the resultant of F1 and F2, but that's not what they're asking, right? What is the question asking? Sorry? There's a third vector in there. And you're trying to figure out what that F is, this third vector. What does that have to be? So the resultant of all three of those vectors is 750 going down the horizontal axis. This is why the concept thing, you got to always do these sanity checks, because you can just go down the rabbit hole and just do all these calculations and not be doing the right thing.
So you forgot about that.
Yeah.
Okay.
So yeah, you guys can try working on it too, or try another problem. Did you find another problem to work on?
The two on the printer are just this one and this one.
Oh, I printed out the wrong thing. Okay, let me print that again. Excuse me.
What are you doing today? Yeah, I'm trying to find this, which is
Okay, here comes some more. Should be printing out a little bit. Yep.
That's just another vector. They don't do the board. So you have to find
And
is that what you mean by cosine squared? Like the quantity squared, or is it like
is it like cosine
big F
60
the
squared?
resultant would be
Is it this is the quantity, right?
well,
To find beta.
mathematicians like to write cosine squared of 60.
all of this.
It's not the cosine of 60 times 60.
I can
It's a cosine
Yeah,
of 60 times the cosine of 60.
Right, so the quantity of cosine 60 squared.
Yep.
Yeah, okay. So I got 45 as beta.
1 equals, well, wait a second. So you got the cosine of beta squared equals 1 minus cosine squared of 60 minus cosine squared of 120. So the cosine of beta equals the square root of that. And equals, so beta is the inverse cosine of that. You got 45 degrees?
Yeah, I don't know if that's, sorry.
Or it could also be what?
Oh, sorry, yeah, minus 45. Yeah.
Not minus 45. Because those 45 and minus 45 have the same sign of the
Oh,
cosine.
yeah.
There's a possibility of having a negative. And the direction angle can only be between 0 and 180. You can't have a negative direction angle.
Negative, whatever.
So it has to be, has to have a cosine,
Yeah.
the opposite sign of the cosine. So like what was this? What was the square root of 1 minus cosine squared minus 60? Because the cosine of 60 is a half, right? So that's
Yeah.
So square on the x-axis.
0.25. So basically it's the square root of a half, right?
Y distributed on the x.
Square root of a half is 0.707.
Okay.
Yeah, right?
Yeah, right.
So this is 0.707.
Okay.
But it's plus or minus 0.707, right?
Right.
Because, you're squaring it, right? So if you had negative 0.707 squared, you're still going to get 1/2 here, which is what
Yeah.
this equals, right? So this equals 1/2,
Okay.
Would that make sense?
right? So,
So then,
That makes sense.
and so the cosine squared, the square of something has to equal that 1/2. That means the cosine of beta could either be
Well, we have to find
plus
0.707 or minus 0.707.
Right, okay.
Okay, now if it's plus 0.707, the angle always has to be between 0 and 180 for the direction angles. It's going to be 45 degrees.
Uh-huh.
But if it's minus 0.707, what angle is going to give you that?
do this, right? Square root.
What angle gives you a cosine of, what angle
not minus.
gives you a cosine of minus 0.707? Not minus 45,
It's
right?
like the 180
Yeah.
degree.
Mhm.
I don't know.
Yes, the complement.
Yeah, the complement.
Or the supplement.
That would be like parallel to it.
Yeah, so what would that be?
This angle.
Trying to do the math real quick. 220
Sometimes the math is real easy if you draw a picture.
Yeah.
So what you got here, you got 45 degrees,
Yeah, so
right?
225.
That is going to give you,
Or the complement. Oh, sorry.
this is going to give you 0.707, and this is going to give you
135.
minus 0.707,
This doesn't
right?
make sense.
Yeah, you add 90 degrees to it.
Yeah.
Well, actually, that's not always true. What you do is this is 45 here, right?
Mhm.
And you go 180 minus 45, you got 135.
Right.
So that's
Okay.
the other angle.
So that could be the other one.
So there could always be these two possibilities. Now, there's one clue as to help you determine which possibility it is, because
Yeah.
looking at the diagram, it's not always clear.
Mm-hmm.
But do you see these little faint lines here?
Yeah.
Those faint lines are drawing the outline of the box
Yeah.
that contains that vector.
Mm-hmm.
And that tells you that, which one of these is correct? Is it
The
correct?
45.
It's 45,
Yeah.
right? Because it's pointing, that box is sort of implying that this thing is pointing,
Like on this side.
it's
of
pointing towards us. It's coming out of the paper,
Yeah, yeah.
kind of towards us, pointing kind of like down towards our feet.
Yeah.
Yeah. So that's
we
why
know
that's
this
45
is
degrees.
45.
So that's the one.
Okay.
That's
So
how you pin it
that's-
down. But it's not sine, it's cosine.
Why is it cosine?
It's always the cosine of the direction angles
For y?
for all of them. Okay, again, it's easy to mix these things up. It froze again. What's going on? Bastard. Nope, it's still going. All right. Still recording. I guess the camera just got freaked out.
So it's always cosine?
Direction angles, right?
Is always
Direction angles are always cosine. Yeah, and we can pull up the slides again, just as a refresher. This was where were we? Okay, scrolling up here. Remember, let's see. See, these are the direction angles, right? And that unit vector is basically, cosine alpha is the x component,
Mhm.
cosine beta is the y component, cosine gamma is the z component.
Okay.
So that's the key.
Okay.
And then you take that and you scale. That's a unit vector, but the magnitude has got to be, in this case, what is the magnitude of that? F2 is 400,
Yeah.
right? So the unit vector going in the direction of F2 has a y component of cosine of beta times j.
Yeah.
But you got to multiply that times 400, which you did. But then, there it is, cosine of 45. Of course, with 45, the sign would be correct, but you would have a conceptual error there. If it was a different angle, you'd get the wrong answer.
Okay, yeah. Because I was thinking it was sine because we're going in the y direction and...
Right.
No, but
you're confusing that with the 2D stuff.
Yeah,
And this is
okay.
the thing to kind of keep straight.
Yeah, okay.
Because the proportionality.
So I gotta calculate all this and
So this angle.
add it up to find out.
Basically now, you're just going to add all those terms together.
Yeah.
it
Are
wouldn't
these
be this
right though for the z?
The z component is, let's see, for F2,
It's subtracted 90.
it's F2. Yeah, because you got the 120, cosine of 120 for the z. It's going to give you negative. Well, actually, you got a double negative here. It's
Yeah.
plus F2
Even though it's
cosine 120.
down?
Because cosine 120 is going to be negative.
So this is gonna be bigger.
The cosine is going to take
Okay,
care of
wait.
the sine.
Right, yeah, eventually we'll get there, but like the way it's set it up...
Put a plus there.
Right, but the way you set this up with just the quantities, I thought it would be down because this vector is pointing down, right?
It is.
Yeah, so
And-
eventually they'd add to
And
cancel. Yeah.
this is going to be negative.
Yes.
Negative 1/2, right?
Okay,
Yeah,
yeah.
so that's the thing. Also, the cosine is taking care of the sine. of
Okay.
these things.
Yeah.
Some of these things you do futz with the sine manually, but with the direction angles, if you put a minus here and then this was a minus, you would end up having a plus,
Yeah.
implying that both are pointing up. You'd have to keep track of that so that you know that this is going to be
Yeah.
pointing down.
I just did that just because I figured this is in the up, this is in the down, just for myself.
Okay,
But yeah, no, I know.
good. As long as you're aware of it. Cool.
Yeah.
So that's cool. Yeah, as long as you get to the right answer.
Yeah.
Like now that you explained it, it sounds right.
Okay, did you guys get this one
Doesn't
figured
make
out?
sense, something like that.
Are you still working on it? Oh, y'all still working on this one? Good. Yeah, these ones are kind of tricky, right? Because it's a little backwards than the normal problem we got. It's not enough to just add them all up. You got to actually derive this third vector. If you'd like a hint, I can give you some.
I was thinking, Tom, so you know how this, if we do the magnitude of this, it just give us like a random resultant.
Yeah, it's not
Force
really the
on
answer
this.
that you're looking for. But you found FR, which is the sum of F1 and F2, right?
Right.
And if you sketch it out, you've got a vector that's going something like this. And it's kind of helpful to draw these things. Drawing
Yeah.
pictures is always a good idea. So you've got,
The x-axis.
an x-axis of 549 and a y of going down of 124.26, whatever, right? And what they're telling you is you got to find an extra vector now that's going to take you all the way to 750 going right over here, right? So
Yeah.
you have to have something here at 750. So you need to find a vector that's going to go from here, like when you add it to the end of that thing, to here.
So then I was thinking.
Graphically, that's one way to do it. And again, there's another, that's the original problem statement, right? And you're trying to figure out what that f is. And what they've done so far, right, is they found the resultant of F1 and F2. You add these two forces together, and you're going to get this resultant, you know, which is
But that's just
that.
between two of them.
But that's just two of them. This third force F, we're going to add to, you know, with these two forces, you're going to get to here, but you got to have this third force take you from here to your goal, which is 750, pointing along the horizontal axis.
Is
Right.
it possible to do it this way? By just adding the third vector that we need and just doing
750 equals a square root of, no, because that's the result.
Well, 750 is the result.
Because 750 is what we need.
Yeah,
right? And
but
then we just need
but
plus.
the F, no, but see, but the F components are gonna,
Yeah, I need.
they're gonna cancel out some of these components, right? Or add to, yeah. So basically, you need to have 750i plus 0j in your total resultant, right? Your
Right,
your
right.
total resultant has to be that.
So then our j just has to be.
You can't do it like that. That's not the right equation. This is actually not correct. So what else can you do?
What are they drawing board?
You draw it again.
Draw it again.
But like this.
You've gotten partway
this is
there.
the
You're almost there.
resultant Vector, so that's
Yes.
the result from these three vectors,
Yeah.
right?
Mm-hmm.
But we have to find this one.
Yes.
So it's like instead of finding the result, we have to find one that will lead us
Yes.
to the result.
Yeah. Do you want some more hints?
Yeah.
Okay. So F can be represented in Cartesian form. You have a vector, you know the magnitude, and you know the angle. What would the Cartesian representation of F
We
be?
don't know that anything yet.
Well, but you have a symbol for them,
Okay,
right?
okay.
So you've labeled them, so you can use those for now. You have basically two unknowns you have to figure out for this problem. And you need to have two equations and two unknowns to find the answer. So if you write that vector f in Cartesian form, it has a magnitude of f and an angle of theta, what would the x component of f be?
This angle right here would be proportional to this. So then that's the same. So then that's how you use it.
F cosine theta.
Yep. So f cosine theta, right? And the y component would be f sine theta.
So 750 equals f cosine theta.
Not quite, but you got to also factor in the x of the, right?
Yeah.
750 equals what? F cosine of theta plus f1x
Oh.
plus f2x, right? And you've already figured out what those are over here,
Oh, okay.
right? And 0 has to equal what? That's the vertical part. 0 has to be
F sine theta.
f sine theta plus what?
The ones that. Yeah,
Plus f1y plus f2y, right? There's your two
But
equations.
we didn't find f1y. We have to.
You already did. No, f1y is here. Here's f1y right there.
Right, yeah, because x, well, okay.
And here's f2y.
Okay.
So we could just.
Just plug it in.
Well, yeah, I mean, FR is the sum of F1x and F2x already, right? So, yeah, so, right. Mm-hmm. Yep. Now you can solve that. That looks a little challenging to solve. It's a nonlinear system of equations, but there's a trick to solving these, and we run into these quite often. So the trick is, yeah, it's two unknowns and two equations, but they're not linear because you got the cosine and sine in there, right? But there's an easy way to solve it. You can write the solution for put f sine theta equals something, and f cosine theta equals something. And then if you divide those two equations, you'll cancel out the f's. So write that out for me. I'll show you.
Yeah.
You get it, right?
Yeah.
Yeah. Wait, that's 200.74? Okay.
Yeah.
Yeah, so if you divide those,
Divide them both
yeah, you can essentially take, since these are all the same, right, you can divide this by this, and that should equal this divided by that. And when you do that, the f's cancel out.
Okay.
And you get the cotangent on the top equals that. So I put one of the, these are sort of all the these are all the trick problems kind of for the assignment. The rest of the ones are all kind of doing this, the same. There's not really any more tricks, I think. So now, well, that means the tangent is 1 over that, and you can take the inverse tangent of that to find out what theta is.
Yeah. So what you did is you subtracted or you added or what? How did you get this?
That's just subtracted.
But is that in newtons? That 549.
Mm-hmm. These are all newtons. Yeah.
Okay.
Yeah.
I mean, I know it derived from newtons.
Yeah, these are all Newton forces.
Okay.
Because
Mhm.
like the cosine is
I think I might have that.
So then what's theta? Not the right number?
not the answer.
That's for, wait, should be 31.8 degrees. And you got what?
58.2.
But you did the arctangent 1.6. It's 1 over 1.6.
Because cosine over sine is cosine.
Mm-hmm. 31.8, right?
What did you do to like the 200.74 and the 1.4.26?
You just divide them.
Oh, it's literally just
So really, f cosine theta over f sine theta can reduce to the cotangent of theta, right? And 200.74 over that equals 1.6, right? Well, we don't have an inverse cotangent on our calculator, right? But we do have an inverse tangent. So you turn that into, you flip it. So it's better to put the sine on top than the cosine. And then you just have the tangent of theta equals 124 over 200. The inverse tangent of that is 31.8 degrees. That's your angle. Now you know theta, you can plug in and find what f is. Did it work out?
Yeah, eventually.
What did you plug into? This is simple. You could plug into either of them, right?
Yep, either one will give you the same answer.
Because, yeah, different number, different cosines.
Super.
Got it?
Great. So, Mark, you've been working on that one the whole time. Do you want to explain the solution to that one for everybody else?
Yeah. Oh, it's Matt, by the way.
Oh, it's Matt. Sorry.
That's okay.
Is there a Mark here? Okay. Sorry. Let's look at the
so
names down.
you draw the picture here to the best that you can. And then, because we're trying to find a resultant vector, you just kind of break down all the forces from F1 and F2 into their X, Y, and Z components. So F1 here, you know, since this is a projection onto the X-axis based on the picture, you'd know that all you'd have to do is write this as F1 times 4/5, because 4/5 is our cosine, and that's headed in the X direction. So we got that. Then for the F2, we know that this is going to be 60 degrees, because that's what's given here. So all we have to say is F2 cosine of 60 degrees for that. And you just plug in the 400 and the 600 in front of them each. So then when you're trying to find y, we know that there isn't really a y force from this one, from F1, because it's a projection onto the x-axis.
Yeah, the shadow, they showed the dotted line going straight to the x-axis. That means there is no y component on that force.
Yeah.
Right.
So you can just forget about it. And then for, so then all you have to worry about is F2, but F2, the y component of it, we actually don't know what that is.
They didn't give you what beta was.
Yeah, they didn't give it to us, so we have to find
So
it.
you had to derive beta,
Um,
just like we did yesterday.
Yeah, and so then you just break it down, because we know that they give us the other two angles. They give us, I guess, alpha and gamma. So you can just square all those values together here with this is your variable. So like this is what you're trying to solve for in here.
Mm-hmm.
So then you just kind of do some algebra, break it out, do a, let's see, where's my cosine? Yeah, you do a cosine inverse here once you get it out of there.
And the
break
tricky
it
thing
down.
about that, and then people kind of get confused by this, you know, is the cosine squared of beta has to equal this value, which when you plug in, these are all, this is, you know, this is a quarter, right, because it's a half square, this is a quarter. So basically you're left with a half, right, the cosine of beta squared. Well, that means the cosine of beta could either be plus or minus 0.707. That's the two possible angles, right? Remember that beta could be to fulfill the mathematics? And so when you take the inverse cosine, you have two possible, well, you know, you got to kind of, sometimes helps to draw a picture. He's got one there, right? This one is when beta is 45, you're going to get 0.707. And when this angle here is 45, this is going to be minus 0.707. Well, that's an angle of, in this case, 135 degrees.
Yeah, so then you have to decide which one it is, and because it's actually in the picture, but it's really faint. They're like,
Yeah, do you see it on the picture? Here again, for the people watching on video, you see the little box they drew on there? That thing there, those little faint lines, that's your clue to tell you which angle is correct, right? If you wanted to know what the box would look like, you know, it'd really be hard to do it on this one. But it could perhaps, it's a little ambiguous, but it looks pretty clear on the drawing too that it's pointing, it's closer to it, right? But on some of them you'll see that it's clearly in the opposite direction. You got to pick the other angle.
So yeah, then you just look at that, and then so then you know it's going to be 45 degrees when you figure out that it's probably not 135, because that's going to be somewhere over here.
Well, no, 135 would be, that's where this angle, you know, that would be like, it's sort of going way over here somewhere, right? But I'm not even showing the thing here. Much, you know, so it would be pointing in the negative y direction. And it's really not there, going there. Sorry, I'm interrupting. Go ahead.
Okay. So then we know that for everything when you're finding the forces from, you have to use the cosine, because I don't remember why you're supposed to use the cosine, but you have to use the cosine when you're trying to figure out what the component forces are, or the directional forces are.
Yeah.
So then that's it for y, because remember we don't have a F1. We don't have a force in the y from F1. And then Fz, just adding up the F1, and this is going to be 3/5, because z's going in this direction. So you know it's going to be 3/5 because this is a 3, 4, 5. And then it's going to be a cosine of 120. I thought it was going down, but since the cosine of 120 is a negative value anyway, it's going to cancel out. Like I originally had this as a minus there, but since it's going to cancel, the minus from this is going to cancel with that. It's going to end up being a plus.
We don't want that because it is going down.
Yeah. So then you just plug them all in, you get all these values. So then you can use these, they're IJK, square them in a square root here, get your resultant, which is that guy right there.
And then you find the alpha, beta, gamma.
Yeah, just put them all over, put each one of these guys over this, and that'll give you your alpha, beta, gamma values for that.
Yeah, it's a lot of work. So yeah, I didn't get that video of the direction angle, projection angle thing on SketchUp, but I have it on my computer at home, so I will post that over the weekend, or probably tonight, so y'all have something to look at. And this video will be online too for people if you don't have a camera.
We're gonna do problems like this off this?
Yeah.
That's cool.
Well, at least this week. And on the final exam, maybe. Yeah, I forget this way. I kind of, because I'm, you know, I steered you guys towards this thing, right? And it's kind of cool to see that, but it's a nonlinear system of equations.
Mm-hmm.
And, you know, sometimes I think there are problems where you kind of have to do that, but Jose got a much more simple approach and more kind of logical, I think, too, when you look at it this way. That he just said, all right, let's just call this F1, F2, you know, the x of these guys, and then you could call this F3 actually just x and y, and your resultant has to be that, right? That's a much more direct approach, right?
Yeah.
That's much cooler. So you solve for x and y, and that gives you the correct x and y for f, and then you can find the magnitude and the angle from those.
Right.
And that worked out okay, right?
Yeah.
Yeah.
Okay,
Cool. Yeah, thanks for sharing that, Jose. Okay.
Yeah.
So tell me your question again.
Yeah, I said like after we found the F1 and F2,
Uh-huh.
I thought F1 and F2 resultant vector, it's F, but it's not, right?
No, it's
Right.
not.
Okay.
F, the resultant, no, has to be here. In fact, the resultant is not drawn on there, right? The resultant has to be this.
Okay.
It has to go straight that way.
Is it a 750?
Yeah, 750, right down the x-axis, because that's what it tells you. 750 directed along the positive x-axis.
Mhm.
That's what that means.
Okay.
That's what the answer, the final thing of all these three has to be.
Okay. So what was the next approach after we found out F1, F2?
Well,
resultant vector?
and this was what Jose did originally, just kind of automatically calculated FR. But this is not really the total result. This is FR for just 1 and 2. He added this together, he added that together, and got this. And that's interesting, but it's not going to be your answer. What that is it's sort of this vector right here. But we needed to add F to it to get to 750, you know, going straightly horizontal.
So can you show them this one? Like the F1 and F2 is, or maybe in that.
Yeah, we could do this. So let's see.
Right here.
So if you just took F1 and F2, you would have this and this, right? Now this is 325, this is 600. This is actually much bigger if you did it to scale. So it's going to be more like that. And what it's saying is, well, okay, that puts you down here at, you know, if you add this using this thing. I'm just sort of sketching it out sort of visually, right? So this is FR, that FR for 1 and 2, I'll call it, right? This is F. They're not even labeled, but this will be F2 and this is F1, right? But you have this third F here, right? And this F is what you have to add to it so that you end up here at 750.
So like we do another resultant vector with f3 and f1 and 2.
You could do it that way
resultant, right?
with two resultants, or, you know, like Jose did the second time was, well, let's just turn f3 into a Cartesian vector, x and y. The sum of all these three things has to be 750. The sum of all these three things has to be 0.
Okay. And the way you were doing it is different now, right?
Yeah, because I'm, you know, I've seen this approach to kind of solving these things, and you can propose that. Well, what we're trying to find is, since we're trying to find the magnitude and the angle, that you can turn that into a Cartesian vector instead of calling this just x and y. In this case, what we're doing is we're calling it, you know, f cosine of theta plus, you know. So in other words, you could think of f as either xi plus yj, which is what Jose did, or you could write it as f cosine of theta I plus f sine theta j.
Okay.
And then that's the third force that you have to add to these other two components, which is what we did here, right? So you have,
So you said this
we have
one-
750 has to equal f cosine of theta, the x component of that force, plus f1x, which is, you know, 5/13 times 325,
Yeah, we get
plus
that.
f2x, which is 600 cosine of 45, right? That has to equal 750.
Cool.
And then the sum of these y components has to equal 0. And so you solve for those,
So
and
what happened to 0 because we don't have y component?
yeah, because it said it's going to be pointing straight down the
Resultant,
x-axis.
okay, cool,
Yeah.
okay.
Yeah.
And then you solve the equation, right?
Yeah.
So you're
You got two equations and two unknowns.
Mhm.
And so it's a little tricky, but, you know, you solve this one for f cosine theta, this one for f sine theta, and then you can divide those two, and the f's cancel out, and then you just get the cotangent of theta equals 1.615, or the tangent of theta equals 1 over that, giving you the angle.
And then you put this back here.
You put this back in. No, you put this back in right here.
Oh, to find
If
f.
31.8 is theta, then, you know, f times the cosine of that has to be 200. Then you can solve for f. This is what you did here. So you did f sine of 31. Is that right?
Okay. Good. Thank you.
Yep.
I just had another question about this one.
Sure.
For it's more of just like a calculator thing, but like when I set this up with the minus part, I just thought that was more intuitive than putting the plus in there. And I know that's like, you know, the minus would come out here and cancel that anyway.
Yeah.
But,
yeah.
So like when I plugged it in here, I get like two different values for those.
What do you mean?
Like, so I put the plus in between and I get a 160, which is right. And I put the minus in between and I get a 560. But I was like, well, wouldn't my calculator know that this quantity is a negative value anyway, the 400 cosine?
It does.
120?
It knows it's a negative value, and then you're negating it, so you're adding
Oh, so,
to 600 times 3/5.
okay. So it wouldn't like catch that and make it, so it wouldn't catch that in here and,
How would you?
yeah, okay.
It
I
doesn't
see.
catch those. It
Yeah,
does what
yeah.
you tell it to do.
No, yeah, I know, but like,
What do you mean? I'm not quite sure what you're saying. That you expect the calculator to say, to know that you mean that since this cosine is negative, that you really want to subtract it and not have to double that and make
well,
it positive?
yeah, because when you plug it in by itself, it knows that it's a negative value.
It knows that cosine of 120 is negative.
Yeah, so times 400 would make it negative.
It would make it
It's
negative,
stay
right.
negative.
But then you're putting a minus in front of that, which is going to negate the negative and make that positive.
Oh, I just never knew that
Yeah.
happened.
Yeah, well, yeah. That
I
happens.
thought it was just new.
Every term is going to be treated with no memory of what's going on before it, and then it just does. That's how the
Right,
that's
because
how the computation's
when you
gonna work.
plug in, when you have like a minus.
Yeah. Hey, I got a phone. I got a
Oh,
call. I got to
sure.
take. Yeah. Hey, Jeff. Hey, how's it going?